it's now 7:37. Basically, it's a small video. Basically, I got my picture. I'm gonna formalize because of the time, because we're gonna go. Formalize the red, green, blue alpha or kilo. Because kilo is weight. I call it kilo because of the weight. I don't call alpha, which is white channel. I call kilo, which is the gray channel, but there's no black channel. But you have a lot of gray, it can be black, but the alpha can be white because it can be transparent. So basically, it's based on opacity, not opaque. If it's opaque, that means you can't see through it. If it's opacity, you can see through it fully. You can have a full measurement of red, green, blue, alpha measurement. Basically, formalize the RGB zoom damping factor of sonar blue. Okay, so basically, I'm trying to formalize. Today, I'm trying to formalize what I call the sonar blue interface. Basically, you're trying to have a dimension ahead of security when it's in booster. For example, say you have a sequence of boost system, you have a color code. Basically, if you remember the Nigerian telly, when you TV boost up, you have what I call test. The test is red, green, blue. But you have Richard of You Gave Butter in Vain, and you have the colors of the rainbow, and you get these colors that have 7 channels, vertical channels. Every time, these are just a pretest before the screen of the color TV starts to go. If you have a red color, if it beeps red, the red color shows, flashes, or glows. Basically, it starts from lowest frequency and goes down to goes to highest, and not be the red glowing, but it is a tone. A tone is beep. Basically, the microwaves are inverse of light, because you get 8 minutes per second. Try to how many minutes does it really? Light travels in 8 minutes from the sun to reach us, and it takes 8 minutes for the sun to reach us. But 8 minutes based on the right, can get the light wave 80 billion. I don't know. It takes 8 minutes for the sun, but for the light waves. So you get the opposite one. 8 minutes. 8 minutes is what? I don't know, but I'm trying to find it now because I won't fuck it up. I hope. How long it takes sunlight to reach Earth? So basically, it takes 8 minutes and 20 seconds. Basically, 150 kilometers, 93 million miles. But this is what I'm saying. It's like so this is what I'm saying. It's like it's not really the point. My point is, this 8 minutes is 8 nanometers. So basically, nanometers is 1,000 less. But they use the measure to twelve. So you have to use the 12 to measure stuff. So you have to take a measurement. This is wait, I forgot. So this is short spot. This is the longest night, but it's so basically it's a geometry. So orbit to the sun to the night, but it takes 8 minutes. In this, we know if the sun just vanished, but 8 minutes is precisely. But 8 minutes means that we have the nanominutes in nanoscale of it. So what happens in the radio system is radio waves are working the negative 80 billionth. So basically 8 billionth. So if you have light 8 minutes, you have to take because they work 1/billion. How many billion? 1/8 billion, 80 billion, because 8 billion. 1 to the power of -8. Because 8 means 20. So we take in nanoseconds. Let me calculate it. 60,000. This is just units times divided by. So 8 divided by 60,000 divided by 60 minutes. So think about it, means 8 minutes is what? 8 minutes is seconds is 8 times 6, 8 times 60. Nanoseconds is 1,000, so 8 to the power of, because you get 8 to the power of every second of the day of the wavelength. So 8 to the power of C00. This would be 60,000, 600,000 per every second, milliseconds, which is 100. per milliseconds is 600 milliseconds, 6,000 milliseconds, million, no, 6,000 millimeters. But nanometers be 60,000. That'll be e to the power of 3,000. That'll be 60,000 to the power of 8. I'm trying to have 1, 2, 3, 4 to the power of 8. I'm not kind of tired, so I'm not good at the power of 8. And that'll be 1.8, 1.68, point 1.6796 1 e plus 39 to be 39 zeros out of the 38 zeros of the it's like 1.67 e. E is an exponential number, so the growth of E is less number, but E plus 38 means E is plus going up positive. So this would be E minus 38 because it's growing downwards, and that would be the measure of the radio wavelength. So the wavelength of this would be that for the light to reach us in 6 minutes, because 60,000 seconds is 1 nanosecond, because 60,000 is 1 millisecond. Is 1 second, so 60,000 would be 1 nanosecond. So 1 to the negative, assuming will stay positive but grow negatively. So this would be from the range of minus to positive because of signals. So this number represents the measurement of wavelength traveling plus 1, 2, 3 to the 8 times. If it's plus 2, not plus 38, here it's plus 1 minute, plus the wavelength, because it has to travel all the way so that's 60 to the power of 8 for 8 minutes. If we go, so 8 minutes 20 seconds, we're not going to 2 seconds again. So we can do 8 26 seconds, but again. So basically, what's today's point? My point today is to give you this number before you go into them. So we get the measurement of a system based on a field. So if you apply a red, green, blue, red means things are moving away from you. Blue means that things are moving closer. You can take red and blue and get a measurement of sign. Sign means the absolute, nothing is there to measure, but sign is not. Sign is like the negative one. Indicating they all share. They share a drift of sign. And sign is like we can't measure it because it's not to measure. Okay. I think blue and alpha is like blue and kilo, which is like 1,000 to the power of 10,000, because we are using wavelengths here. So we started 10, so we added 1. It's a problem. So the growth E is what is because you remember these are units here for yourself. So if you get an R, you get imagine if you get the power, you get a number. But so if you're measuring red, green, you measure what sign. If you measure green, blue, you measure yellow. Yellow is between red, green, blue. No, green and blue you have yellow. This is cyan color one, because cyan means your the symbol is rose. So why cyan matters? Cyan, yellow, magenta and black. Cyan, yellow, magenta and black. Okay. This is just point out to the data, but magenta is the color. There's no there. Sign between there's no there between so between yellow, between green and blue, there's yellow. Nothing. That means we're both moving away. We'll go until we're moving away, but two ends away from the measure. And we're taking the current measure of the system because it works on a mirror because it's practical, because it works on red shift. And radios are the first way to do this, because I'm trying to get color, distort this color as a radio. So you get magenta, so you get a sequence of bytes, but you get magenta, which is like the light spectrum. So you can use this kind of color coded, and then black or white. If you get black, that means you get no information. You get white, that means you get all the information. There can be noise. If you get black, you get all the information. So you get if you have black, and black means you have noise, or noise or you have no noise, or you have no signal. But this means that this black means you're not getting anything with your target, with your goal, or the shared goal we all have, good or bad. That's what Mmuko matters. The spirit of good and bad, the spirit of good and evil that affect them. The spirit of good and evil that binds us and them all, whether we like it or not. That's the really one of it, because you're and it gives measurement of black. So black can be white to them. My black is your white. If they get white, if we get white, basically, if I have a dimensionless, if the 3D being is observing my state, in the 3D work, because they got a model of it. Black is what the one see my rear here, so she became black, but they can observe black if I'm moving away. They'll see white if I'm moving away, still moving away. They can measure me, so I'm gonna throw because that's basically you go to test. I'm gonna test something. You get a paper, you draw lines on a paper, and you get a needle, and the more you draw the line, it cuts that the line will cut it 6 over 10 times. 64% of the time, the needle will land if it's equidistant. The more you define the needle, the section of the needle, the more precisely you are able to drift away. So it's a measure of drift. Basically, so it's not an arbitrary test. If you take a piece of paper and you take, for example, a 5 centimeter, because 5 centimeter needle, and you take the 5 centimeter. Okay, no, it's 4.5 centimeters a needle. 4.5 centimeters a needle, and you get a rectangle, get any shape, any plane, and you drop that needle, and you take length of the needle to draw the lines. Yeah, you gotta know. 64% of the time, you can. The more you do it, the more numbers you get. The more numbers you get, the more you can compute pi. Now pi means 3.14, because 60% of the time, and you get pi, because pi means there's something that happens drifting away, and things are popping, are existing, because there's so the length of the needle is very significant, because you're dropping it from any height, and the more force or the fermions that affect the system. Collateral question is, if you're in a dimension and someone's coming to you, you can measure that thing, and that's why it's measurable. That's why the drift matters. Because if it's moving to you, if something's moving to you from a dimension, you can measure it. You can measure before it happens. Because Mmuko, tell me if it is what. Tell me if it is what a TY. Now the two tell me if it's what Mmuko OS is a echo relay system, because you can hack it. Why is it an echo relay system? It's a plastic cushion. It doesn't matter who's operating it. If there's some kind of ambiguity in the system, you have to know ahead of time to address it. And that's why you want to, the security flaw. It's the real echo server. So if I type in hi on a terminal, I expect echo hi, and I run that every 10 seconds. I should get hi, but if the program is executing or the file, any file after the get compile gets altered, you can get hi and shell hijack. It doesn't matter when it's happening or not. The shell be hijacked because you can't relay the system. So basically, my Mmuko terminal, terminal interfaces, we have 10 terminal, 10 TY minimum, because we have 80 TY, we have 80 human rights, but we have 80 minus 40 TY. No, because we've got each human rights, each unit is worth 64. You see, 16 TUI. Because I don't trust people, I made it a plus 4. That'll be 20 TUI. There's more, there's a reserved TUI. And half of those reserves get 8 plus 8 is 16. 16 plus 4 is 32. No, this is 16 plus 8. I don't know. 16 plus 8 would be. Oh no. Oh! 16 plus 8 would be, if you get 20 TUI, so you get a 20 TUI, get 10 TUI, and get 40 TUI processes that run at a time. One is better, because the Mmuko allows you to do all things, live, work, and breathe while you're always downloading, so you're not bored. Because, it's about you diverging with ADHD, space and time. You can, that's good, you can play games. But the games are mini games to keep you engaged. You watch videos already downloaded, and you can't clean them, because those videos can be used for verification too. So you'll continue. If you trust with them, that means you will keep them as a policy. So you don't get them removed as a policy now. Because it doesn't matter what's my video. It's also what this is about my country, all my work in them. Because it's about intellectual fun and games. I'm playing my record. Basically, I call them ghost games because you're playing with me offline. You're playing, being a record. Basically, you download the update, you download the new ghost. It has to be that ghost while you're like a racing game, ping pong game, no ping pong, no ping pong games, no simple games, but like that. But retro games that I found like Mario, but made by me, that kind of game. You have the Ghost Racer that you can fly, or it's an AI system, but it's not really free an AI system. It's something that can be an AI, but it's not AI. We can fight against it while you're downloading. So when you actually show, so this part no start process of policy because no start report. So how does this work? This is like a session graph. So basically, the more you play it, the more games you play it, the more more you preserve because you are actually helping the system keep idle. And you actually use some money dollars. And this is very good as a policy now. So the second project is this. So Mmuko is a no. So basically, you got this now. So basically, the other thing is how this works. So you get the 32-bit architecture to default. So we have a shared 16-bit. But everything 16-bit is kind of like a USB stick. So you can get a USB stick of 260 to the power of 2, 255, 256 megabytes or kilobytes of data. If I want to run an SD card, I don't know but I want to back up on an SD card, something like an SD card. But I want this Steam to you get 2 point, 32 to the 4-bit x86, and because cost platform, then you just do it on any hardware via the noise filter, noise flash, literally. So the pointer problem is, so when you're living, you should be breathing. When you're breathing, you should be living because there's no difference. If you can, it allows you a degree of freedom because the humorous also this is so basically the thing about pain is you're gonna have to have a mosaic memory system because when you so you have a red cone, a green cone, and a blue cone. Those are the screen codes, but you have to light up, and do some pretest or stress test because it's like my TV when it turns on. When my TV turns on in Nigeria, it goes beep or beep, but when you set it up with an Alex, the radio is when you have a wave that you're measuring the wave, you start getting channels, but the channels are interactive. But you start to download it. Now the download is very good, but I love the download process because it works in real time. So the download process works. So for example, red, green, blue, like you get the channels on red, but I love them because the leadership picks on it. So the Russians just encode that. Love the state, the state is still does. It's just at this spot where the channel is, so it doesn't lose again. Because downloading more channels is not really the problem. It's a system frequency. So I'm not gonna end the video to show you how this works in the formal practical sense of the word. The lobbyist, the law, assembly, everything else. No. Yes. So basically, the problem is on shape and structure. So everything is a structure. Anything geometry is structured. Anything with a shape has structure, but that structure is in a imaginary unit. So it's a shape, but that shape is a structure in its own dimension. This is what dimensional quantities are. You can see what dimensional quantities are because they give shape to structure. They give structure to shape. And vice versa. They work on bidirectional. So I'm going to play this video. So this is the YouTube video I want to play. 3 equals negative. So this video is about shape and structure. So I'm going to play it.
8 blocks. It looks like an L. But Ramanujan realized this shape is just a disguised rectangle. Height 2, width 4. So 3 is actually the square root of 1 plus 2 times 4. This geometric rule works for any number. Take a square, remove 1, and you get a rectangle of neighbors. So Ramanujan looked at the 4 in his equation and applied the exact same logic. 4 is the square root of 1 plus 3 times 5. So he took this value and plugged it back into the top equation. He realized he could keep going forever. The 5 becomes 1 plus 4 times 6. The 6 opens up even further. And that is how Ramanujan proved that this terrifying infinite monster is simply the number 3 in disguise. In 1911, the Indian...
So basically, this is the Raman riddle. The Ramanujan riddle, basically this is just a signal processing. If you can think something, you think in noise, well, some information. It doesn't matter if it's a character that's heterogeneous, your construction of it is sparse, but it's a signal. So you're trying to get what we call signals, which are imaginary units for what is sparse model of how the data is. Which we usually talk about the analog signal, give Fourier series, but they're just these equations of analog signals. The Fourier series are sequences that allow bit. So if you're downloading some kind of article, you can verify this with a system that has a zero coincidence. But the main problem that the Raman reader has, if you get some artifact that you can't check why it's downloaded, you can just load it up, and you just build a virus because it looks the same, it feels the same. books and lapis of energy because you just done it like a mirror of Mmuko S and the Mmuko S is done. So the Riemann riddle, the Riemann riddle is basically if you get a number 3, 3 has a shape. Had a shape. The shape means like we can have 3 as in a tally 1, 2, 3, or 3 eyes. But these 3 eyes are just 3 lines. We can have 3 as a number 3. You can have it backwards 3, because this backwards 3 is just 3, but in your frame of reference, if you're thinking about so using this, but this number 3 backwards, you're doing it. It's a symbol, but that symbol has a shape. And that shape is quantifiable. So these are dimensionless quantities because they work on the imaginary unit. When someone's talking about this, which you just know, this signal means this. These are the signals of. That's why because they work on the dimensions of how we conceptualize this. But the quantum is just these signals because these signals are what we use as sparse model. No matter how the code is, there's signals that can literally. Direct understanding of what the polar coordinate system collision if we never observe them. If I explain to the beginner. So let me play a video game. Number 3, 2, 1. Time is now 7:44.
Genius Srinivasa Ramanujan posed a problem that stumped the mathematical world. It looks like a monster, an infinite nesting of square roots. Most mathematicians tried to solve it by calculating from the inside out, but you can't start at infinity. Ramanujan didn't look at numbers as symbols, he saw them as shapes. To solve this, he didn't calculate forward. He started with the answer, the number 3. Visualize 3 squared. It's a grid of 9 blocks. Now watch what happens if we remove exactly 1 block. We are left with 8 blocks. It looks like an L. But Ramanujan realized this shape is just a disguised rectangle. Height 2, width 4. So 3 is actually the square root of 1 plus 2 times 4. This geometric rule works for any number. Take a square, remove 1, and you get a rectangle of neighbors. So Ramanujan looked at the 4 in his equation and applied the exact same logic. 4 is the square root of 1 plus 3 times 5. So he took this value and plugged it back into the top equation. He realized he could keep going forever. The 5 becomes 1 plus 4 times.
So what is going to say? So this 3 is has a shape, and that shape is 1 plus the square root of 2 plus 4. No, 1 plus square root of 2 plus 4. 2 plus 4 is the GCD when you get 8. But this 8 is an even number. This 8 is an even number. So I'm saying when you get 8, you get 2 and 4. 2 and 4. You can get 2 and 4. But these 2 and 4 have some operations you can get. In the imaginary, you can get 8. So let's try this. So get 4i plus 2. 4 imagine numbers plus 2. Or you can get 2i plus 4. 2i plus 4. And these are 2 valid signals. Plus or minus, they'll give you, plus and or minus, they'll give you 8 when you go through some rotation. But this 8 is the canonical local, this 8 has a local common model that binds by the and lowest common multiple of 8 is 2 and 4. They can give you the common multiple. That's the lowest. The lowest multiple is 1, 2, and 4. So these are the signals of what the imaginary units of 8 are 4i plus 2 or minus 2, depending on the frame of reference you are operating. You get 2i plus 4. So this is a problem. These are signals to the number 3. 8, and this is 8 signal. This is 8 in the row sets of the world. If we all share that 8, the shape of this is a matrix. 2i, well, plus or minus 4, or 4i plus or minus 2 to give you the 8 row 8. But I like to do something. I like to do something else. So 3. However, you get the square root of the square root of this. So the square root of 1 of this kind of conversation. Square root of 1 is irrational, which is negative I. Square root of 1 is I. Square I times I. Square I is 1. Square root of I 1 times 1 is negative 1. So the square root of 1 is I. So this I times will be irrational. So you get plus or minus 8. Plus or minus 3, plus or minus 1, which would be minus I. This is imaginary I times will have to be applied as a signal in the motion, in the reflection rotation. I times 2, 2I times 2, I will be 2 times I will be 2I, I times I is I, and then 2 times I is 1. So I times 2I is what? I times 2I is 1. I times I is negative 1, and negative 1 times 2 is negative 2. The same for 4I, from get 2, negative 2, negative 2I times 4, negative times 4 will be negative 8. So negative 2, get negative 2 and negative 8. It's going to detect the location of the system, negative 8, negative 2, but these are literally corner points that determine the number 3. What does 3 feel like? You know what I'm saying? If you have a Laplace integration, which is like a if you have a sensor like a model to the city, if you have a pressure sensor, can take the power, which is lambda 1. So 3 is equal to this kind of shape, 1 plus 2. Now 3 is the only number you can learn. This is like the signals of the shape. So why this matters is because the only you can take any color and distill it for neurodiverse for the eyes too, but to prevent blindness, this kind of is like a forgery trick, because my eyes, I can't take straight away, so it adjusts you because you humorize too, but it has to be as a policy that goes down, because it makes you look like that shit, Okay, so this kind of thing is like quadratically down by the system of. So yeah. So, this number can be, you can give all the initial values that we should to give some coded into the system. So, basically, this is where what are we talking about? Doesn't matter if you have a tally of 3, the symbol is 3, and we're thinking about 3 by 10, like Greek times. The power of the signal interface is that numerically you get the symbols, which are glyphs, that mean something. Basically, glyphs are symbols that mean something, have meaning, and those meaning are weight, and the symbols can mean nothing and be artistic too. So we have some kind of human compliance interface, Hermes advocacy compliance cycle that benefits for no-gossip person. Every workplace must contain reference to flow data, and the signal interface is mandatory as a policy to be as an invariant policy, which is what I'm looking now for my Mmuko mic, F for mic, F for mic, U for umbrella, O for kilo, O for Oscar dash operating system, O for OS on github.com/O for Oscar, B for Bravo, I for Indigo, K for kilo, I for Indigo, S for November, E for Echo, S for Esro, U for umbrella, S for Esro. This is Mmuko. So the goal of this is literally to use the Riemann problem to determine what is the shape and what all shape does everyone have in a tomographic landscape via metaphysics. What is computable, what is knowable, that we all should know, determining the nature of computation. Like, the tallying 3 or writing down backwards 3, because that 3 has the logical reference to your work. Because I love a CBD, and the CBD is a sparse single protocol, and the single protocol is a humanized protocol. So the single protocol, influenced by ISO Sarah, I for Indigo, G for Golf, I for India, I for India, is literally bound by this kind of reference framework. You can get access of chemicality that's entirely dimensionless quantity, which are signals that propagate to give that we all measure ontologically, but can get wrong, but essentially never correct. It's computer based on how the human rights protocol operate. Thinking and try to have an implementation of it. For example, in Singapore, you get access A to Z, and Z to A, but this XYZ access, you get a trident access of it to give you a dimension, but that equals to pi, so you have to get a message of whether you lose information. So you get a packet, you get a point of it. So you can be those 2 meanings, 2 interpretations, because you don't know how to more set and preset. So using Python and using Python ASCII code from I did a library because you don't have UTF-8 encoding, or if you can see to send a secret message for food or something, you want to ensure that all you did was really safe. Really safe, because you just send a message. We don't want to be the relay system. Make sure you get a message and the food items. Thank you, Namdi. Because the secret was an access, trying access.